I have already shared this, discussed this particular slide program with you. But before we get into the details, I would like to discuss that programming one will be discussed by Raghav sir, and programming three will also be discussed by him. What I will be discussing is the second part, which involves arrays and slightly complex things, certain things, but primarily arrays, uh, and how do you write those programs. I will also discuss something else, but then this is the first thing related to the project work. The practical. If there is anybody who cannot see the presentation, my shared slides, you can unmute yourself and speak out. So if there is any problem with the sharing or my voice or whatever I'm showing, you can unmute yourself and speak out. I would not recommend you to write it on the chat. You can do that, but you should also speak out, because I may not be able to see the chat messages. So the first thing is one thing I will be discussing is the algorithms for this part. Division of complex numbers, sorting exercise, addition and multiplication of matrices, carrying out transpose of a matrix. So the algorithms will be discussed. It will never be shared with you. You have to note down those algorithms. You can get those algorithms anywhere else also. But I would like to go through those algorithms. And then I'll also discuss one of the feature, this something called GNU plot, how to use GNU plot for plotting data and functions and various things that it can do. Some of the features that we will see in this programming exercise. Okay, all this can be done either on a laptop or a mobile desktop, as well as on a mobile. You can install a mobile compiler app, where you can write programs, or you can use the online one. What I am going to show you is discuss the whole thing on my laptop, how to write programs and how to carry out things on the how to use GNU plot on a laptop. And then once I do that, I'll also show you the demo of how to do the same thing on a mobile app, how to use this particular website on mobile app. Okay, so let's start with this. I'll probably go a little faster on this. This is I'd first like to discuss what is the idea behind programming, and then discuss certain components of programming which is independent of C, C++, R, Python, or any damn language. It is independent of any language. So I would like to discuss those that feature first before going over to the algorithms or the C programming language. I will also discuss what are the features of C programming language. I will also show you how to write it. And then in next few days, I will also try to see if I can record certain lectures on C programming language and share it with you. So I would like to share a few lectures on C programming language, which cannot be done in a very short period. So I would like to record it and share it with you. Okay. So basically, when it comes to programming, there are three basic concepts. One is what actually is the programming. What do you mean by programming? Then the second part is basically what are the certain concepts of programming, how one can use those programming. What is programming? What are the features, components of programming? And then finally, what are the different strategies that one can use to carry out this programming? Because when you want to write any program, having some idea about this is always a good thing. And one of the strategies involves something called algorithms Algorithms are flowcharts. Algorithms and flowcharts. So what are these algorithms and flowcharts, and what are the significance of these? We will see. Basically, what is programming? Programming is nothing but it is just a set of instructions which are given to the computer to make it work. Basically, it's not necessarily to a computer. It could be a set of instructions to be given to anything. So that it's like a recipe. For example, if you want to make a sandwich, what are the things that you would like to know? If you want to make a sandwich, you need 2 slices of bread, some cheese, some sliced vegetables, and various ingredients that you would like to add it to the sandwich. Then what you do is you apply cheese, you apply mayonnaise, sauce, and all those on the bread, and then put put vegetables on one of the slice, and then put the second slice on top of this. That is basically the procedure to make a sandwich. Another very good example is if you want to go to withdraw money from an ATM machine. The first thing that you need to do is first go to the ATM machine. Once you reach the ATM machine, open the door. That is one step. You have to. It could be opened already, but open the door if closed. Get into the ATM machine. Take out the ATM card. Insert it into the slot given for the ATM slot, ATM machine, ATM card, and then basically follow the instructions. Among follow the instructions, what we need to do is first put the PIN number or choose the language, put the PIN number, enter the amount that you would like to withdraw, press OK, and then withdraw. After you do that, take out the money, take out the ATM card, put it back into your wallet, and then walk out. If you miss out any of this step, any one of the steps, if you forget, you are likely to get messed up. Things are going to get messed up. For example, if you may forget to enter the PIN, which will not allow you to withdraw money. If you forget to take the money, which beats the whole purpose of going to the ATM. If you forget to take out the ATM card, it can be very problematic later on. So any step, if you miss out, could be a problem. It could mess up things. So any task, when you divide it into smaller steps, it's an instruction. It can be converted into an instruction which is to be given. It could be given to a person that you have to do these things, and when the person follows those instructions, he is able to get things done. So the same thing is with the computer. Computer has to be given a certain set of specific instructions, as this says, specific task. Specific instruction has to be given, and it need to be extremely specific. So specific that when you say child, don't do this, do that, he understands what is to be done. He may or may not follow the instruction, but he at least know what is to be done and what is told to the child. Whether the child is 1 year old or 6 months old, the child will probably know, but computer will never be able to know what is to be done unless every detail is given to the computer. So computer is completely much worse than a newborn child. Why is this? What is included in this programming? Why is this required? It's because a program, there could be many tasks which could be repetitious, which need to be repeated again and again. And if you want to do it again and again, and if you have to do it for thousands of times, millions of times, trillions of times, it becomes beyond the human patience or capacity to do it. But a machine may be able to do it much faster in a much controlled way. So allowing the computer to machine to do this is useful, and so we need a programming, and we have a much better control over the machine compared to a human. Humans are likely to make errors, machines are likely to not to make errors. Any error made by the machines essentially because of the errors coming from the humans. So there is a high degree of accuracy when it comes to machines, and there is a high speed required. There are many examples, but I will not get into those examples. But there are many, most of the places where one would like to do things with extremely high accuracy and with extreme high speed. For example, you want to buy a ticket, a Tatkal ticket. You would like to do it in less than 10 seconds or maybe 20 seconds. That's the time. Within 20 seconds, if your ticket is booked, you are likely to get a confirmed ticket. Otherwise, it goes into waiting, and that waiting doesn't really get it converted into confirmed ticket. If it is Tatkal during the peak hours, and I am sure most of you might have experience about that. And if you have to do it manually, it becomes much more complex. So you need a computer to do this. If you are able to, well, a lot of people do it through computers automatically. Without actually doing everything from the keyboard. There are ways of doing it manually, automatically. That is likely to give you more chances of getting a confirmed ticket. Well, okay. What are the features of programming concept? What are the different concepts? There are certain concepts in programming which is associated with each programming language. Each of the programming language requires a sequence of commands. There is always a sequence of commands, and in a particular order. It has to be in a particular order. It cannot be, the sequence cannot be interchanged at random. There could be flexibility to some extent, but it cannot be completely random. You just have to, you just can't say, for example, while making sandwich, you can say that I'll put all the vegetables first and then put cheese and I'll put mayonnaise and sauce on the bread later on. No, you have to put mayonnaise and sauce before you put the vegetables, or you can't withdraw money without putting the pin. So there are certain things sequence. So that sequence has to be maintained properly, and every command has to be in the proper order. Then there could be certain conditional structures based on what is being seen. For example, when you enter ATM, if the door is closed, if the door is closed, open it. And if it asks for a language, first you select the language. It may happen that it may ask for a pin and then ask for something else. So depending on that if condition, you proceed further to the next stage. So those are called conditional structures. And then there could be something called looping, where you carry out the particular set of instructions again and again. So if you have to do those set of instructions, so same thing again and again, you put it in loop. For example, you have to carry out, you have to make 100 sandwiches. The procedure for one sandwich is exactly same as that of 100 sandwiches, but then that goes into loop. The procedure has to be followed again and again. So that is a looping structure. So these are the three basic features which are required in a programming language, any programming language. What are the strategies? Basically, there are several strategies. There are a couple of where I didn't. I should have done it. There's some mistake here, but anyway, there is a top-down approach. Yeah, top-down, or it could be a bottom-up approach. So there is a top-down or bottom-up approach. and then there's something called pseudocode approach. And then these are this top-down approach. These are basically your flowchart, and this is essentially your algorithm. This is algorithm, and this is essentially related to the flowchart. We'll see those things in a minute. Okay. In the top-down approach, you map up the entire program with major components. We use flowcharts and general statements to represent certain logical flow. And then there could be components boxes of various shapes and sizes, which corresponds to a set of can be converted into a set of instructions. Then another approach is the pseudocode approach, which is essentially the algorithmic approach, where you convert the same flowchart or the chart, which is consists of boxes. We convert it into a simple English language or any language that could be comfortable to you, something which can be understood by humans very easily. And then you convert those into one by one into a programming language equivalent, and then write the program. For example, this is an example of finding out which of the number is largest between A and B. So you are given two numbers A and B. We would like to find out which is the larger. So algorithm is the following. First you read in A, B, two numbers, and then say if A is less than B, then big is equal to A and small is equal to A. Big is equal to B and small is equal to A. Else it's the other way around, and we can display big number as first and the small number later. So this is how the algorithm is written. The same algorithm can be written in a flowchart form, which is top-down approach. There is a start. Whenever you write a flowchart, there is a start, there is a stop, which probably may not have any equivalent statement in a particular language. May or may not have. It's not necessarily that it should have. Most of the time, start may have a equivalent, but stop need not have, or may not be there in that particular program. It may be there in the feature, the programming feature language, but you may not necessarily use it. Then this is a statement which input statement, input output. This parallelogram shaped structure is basically used for input output. I'll discuss those different boxes in the next slide. And then it goes to a diamond shaped box, which is a decision making. So if the decision which says if A is less than B, then big is equal to B, small is equal to A, otherwise the other way around, and then write the output and stop. So this is how you write a flowchart. And many times flowcharts are easier to convey things in a pictorial form, and many times it becomes very clear as to what is happening in a particular program. But that doesn't give you a much detailed thing as to how to program it. For program, you need the algorithm which was discussed earlier. Okay, so what are the different shapes? If you have an oval shape, it denotes the beginning or end of a program. That beginning and end may not have any significance in actual writing the program, but in order to know where the program starts. For example, if I remove this particular box, it could be very difficult to know where to start with. It may be difficult to understand where to start with. That's the reason it's always good to know where to start, so that you know where to start the programming, which is the first statements to be written for programming, and where to end. So for that purpose, you use the oval shaped boxes. Then this is the line where which shows the direction where to go. This parallelogram denotes the input and output. That rectangular decision tells what is to be carried out. General statement. It could be addition, multiplication. It could be hundreds of other things that could be carried out. The diamond shaped structure is basically it denotes a decision, a conditional loop. Based on the condition, you can go to the right or to the left, or you can go to the next step. Okay. So these are the basic features of programming language. I'll just yeah. All these features are already built into one of the programming language called C, which was given by which was designed by Dennis Ritchie and Kernighan and Ritchie. There were two people. Dennis Ritchie. This was in 60s. I think in 60s, when he wanted to write a Unix when he wanted to write a Linux not Linux, Unix programming language, which could be used for which can have a much more better control over the different features of the hardware. For that purpose, he designed a new programming language. At that time, there was a programming language in use which was called B programming language. And because of that, when he came up with his own language, he called this language as C. And from that onwards, this language is being continued as C programming language. It has something called data types. We'll see all these features. I'll discuss different features of this programming in a little bit more detail. Give a whole summary of C programming language. This is just a list of things which are there in the C programming language. So it has something called data types. So whenever you write a program, you would need integers, you need real numbers, you may need complex numbers, you may need something like matrices, because when it comes to physics, most of us work with one-dimensional and multi-dimensional matrices. It could be a column matrix, it could be a square matrix, or it could be any other kind of matrices. So, but then those matrices could be of real valued, or it could be complex valued. There are certain constants. For example, the charge of an electron is a constant, Boltzmann constant, Planck's constant. These are constants, so which will not change value. So, like certain variables, certain types which can change values, and then certain variables, certain quantities which can remain constant. So those are categorized into data types, so that one can use, one can carry out one can write programs. Then there is something called operators. These operators are not same as the operators in quantum mechanics. Quantum mechanics, you have certain operators. Matrix is a representation of an operator, which has nothing to do with the operators in this programming language. Operators means, for example, addition. Plus symbol is an operator because it is operating it is operated on two different quantities. It could be real, it could be integer, or a real or anything else. So there are two quantities which you are trying to add or subtract. So if it is addition, it's a plus sign. That's the operator. That kind of operator is called binary because it requires two inputs, either on both sides. There could be operators which can require only one input, which is on one side, left side or right side. There are something called bitwise operators. There are logical operators. There should have been one more. There are something called logical operators, which says which tells you about the condition, whether number is greater than or greater than a certain number or less than, and so forth. Using these operators, one can write expressions, mathematical expressions, which could be which are essentially which are essentially which could be arithmetic operations or expressions. Arithmetic operations means basically equations, which may involve in principle some logical conditions, but mostly it involves normal operators like addition, subtraction, multiplication, division. Then there are some more operators, which I'll give you a list of operators when I discuss C programming language. And then there could be logical operators. Operations are logical expressions, which contains of logical operators and some expressions, something which will tell you the conditions. Then there is something called control flow. For example, based on certain condition, we would like to do this or would like to do something else. So there could be there's something called if condition. There's something called do while condition, and many other features are there which can allow you to control what is to be done. You would like to carry out task multiple times. For that, you need features which are loops. So there are ways of carrying out running a loop, carrying out the same activities again and again. That's called, one of the loop is called, for example, for loop, which can be used to repeat certain set of instructions. You may also like to assign multiple values but with the same name. For example, name of the student. So for example, if you have there are some 68 students in your class, you'd like to put roll numbers and their marks. So what I would do is I can create a single variable which will have the values which will have indices going from 1 to 68, and then something like AI, something like this, which are conventionally written in mathematics as AI, like this. So the variable A could be my roll number or it could be marks, and this index will go from 1 to 68, and then the variable A1 will have roll number 1, A2 will have the roll number 2, or marks of first roll number 1, marks of roll number 2, and so forth. So that kind of features require a concept called arrays, which are there in the C programming language. There are pointers, which we will not discuss. This is something which you can work out yourself, which we will not be using mostly. So I will not discuss that part. Then there are something called functions. So you can categorize that certain task combine. If it is to be repeated again and again, you can separate it from the main program and then write a small program which is called again and again from the main program. So some kind of sub program is called functions, and that saves a lot of time and it makes the program more readable. We'll see how to write those programs. And obviously, one of the most important feature is called input output. How to read in input from the screen, from the user, from a file, and how to write it onto the file, onto the screen. There are something called structures, which will not be discussed again. You need to do a self-study on this structure, and obviously this is something which you may this is related to the microprocessor programming. If you have ever done microprocessor programming in the earlier classes last year, you will realize that it's really the same thing but slightly updated, modified one. One can actually work with lower level, the hardware level. You can talk to the hardware through C programming, which is possible only with C programming. So those features are also there in C programming, which will not be discussed. So anything pointers, structures, and low-level programming will not be discussed in this, and will not be required. Okay. The timing is till 1:30, so I think I should be able to finish it by 1:30. Five phases of machine computation there are certain if you when you are given a certain program, certain tasks to be carried out on a computer, by writing a program. First thing that you need to do is there are 5 phases of that. First thing is you need to choose a method. Which method will be most suitable? That is one thing that we would like to identify. And then once you identify the method, you need to understand the algorithm and design it. You may need to convert it into a flow chart if needed, but that's kind of optional. Then you actually write the program. And after you write the program, you execute it. And if you find any error, and if it is not doing the things that you are supposed to do, you go back to step number 2 or maybe step number 1, depending on what is to be done. Mostly you need to go back to step number 2, understand the algorithm, whether there is any mistake in the algorithm, rectify it, and then go to the go up to step number 5. It may happen that you may have to go to step number 1 in case if you need more accuracy, faster results. So if you want to change the method which could be more efficient in the sense it is faster, or if it is more accurate. So in that case, you may need to choose a different method. So you may need to go from here to there in that case, or most of the time you can go up to here, step number 2, and then get the things done. But to improve result, you have to change your method. So these are the steps. Let's look at one of the examples, which is also part of programming 1. This is a simple exercise, so I will like to discuss this. Quadratic equation. Okay, before I get into the quadratic equation, I would like to see. Yeah, maybe I have stopped the presentation. I stopped the sharing part, and I would like to see if you need any, if there is any problem with, so far. Are you able to? This? Yeah. So what I have discussed right now is general features of of programming. What are the features in that? I would like to now discuss the algorithms, all the algorithms, and then come back to programming. And then most likely the programming can be discussed in the post lunch session as to what are the features of C programming, and then write the programming, as well as look at what you are supposed to do in a GNU plot. Okay, so tell me, I don't know how many of you are still following. So, okay, yeah. So, is this well? This is something which was very generic. So, I don't think in case if you are not fully, if you are not able to understand this fully, you can still go back to the notes, to the video which I will be sharing, and you can try to understand those things. So if you have any question regarding this, please let me know, so that I can discuss those and then proceed to the next step. So is there any do you have any questions regarding the features of programming? This is something which is very generic one, not specific to any particular programming language. Okay, so can move on to the next part. I'll start again. I'm sharing the presentation. Yeah. Okay, I'm sharing the slide. All of you are able to see this slide? Quadratic equation. I'll discuss the algorithm for this. I don't know whether I have programmed for that, but I would like you to note down the algorithm properly, and I will discuss the program for this particular for finding out the roots of a quadratic equation. There are various ways of doing this. There is something called iterative method, but I will discuss the direct method, which is mentioned here. So the quadratic equation is given here, which is ax square plus bx plus c equal to 0, where a, b, c are real. We will prefer to stick to real numbers, and the roots are given, which is very well known. Now I would like to carry out this calculate x1 and x2. Given a, b, c, would like to find out the values of x1 and x2. What are the steps? What are the algorithm? What is the algorithm? This is the algorithm. First, find out a, b, read in a, b, and c. Once you read in a, b, and c, then check whether a is equal to 0 or not. If a is equal to 0, which means that there is something wrong in the program. You just cannot use the formula, because the formula is like this. The formula has a in the denominator. You cannot use the formula. And the reason is because when a is equal to 0, the equation does not remain quadratic. It becomes linear, and the method has to be different. That's the reason. If a is equal to 0, the formula for quadratic equation cannot be applied to this. If it is not 0, then calculate this quantity called d, which is equal to b square minus 4ac. If d is negative, which means that the roots are complex, and if the roots are complex, you can either cannot make it negative and then find out the real and imaginary part, or you can skip to the last point, go to the last step, which is top. If d is positive, then you calculate e, which is equal to square root of d. And once you calculate the square root of e, use formula for x1 and x2, which is basically given here, minus b plus e upon 2a minus b plus e minus e upon 2a. So these are two formulas, and you can calculate the roots from this, and then you can print those formula. So this is the steps involved in quadratic equation. All these steps can be directly converted into a programming language. This is another example. Okay, I will not get into that other example. Is there any doubt? Do you have any question about this particular algorithm? I'm not talking about how to solve quadratic equation, but I'm asking you to know whether is there any complication in writing the algorithm. I'm not teaching you how to solve quadratic equation. I'm teaching you how to write an algorithm. I would like you to understand how to write an algorithm. Once you know how to write an algorithm, you should be able to write algorithm for more complex functions, more complex tasks. So dividing the whole thing into 5 and 6. Okay. Maybe what I can do is I can write this program also. Let me see first. After verifying that it is a quadratic equation, which means that a is not equal to 0, which means that then you calculate this d, which is equal to b square minus 4ac. You divide, if that is negative, it's a complex number, but if it is positive, then you calculate the square root of this function, b square minus 4ac. B square minus 4ac is given by root of that is nothing but e. That's the reason you calculate square root of e. This is sqrt is a function right now. I've just put it as a function because most of the programming language will have the same name, sqrt. Almost all most of the function programming language uses exactly the same keyword sqrt, which is square root of d. This one is basically square root. This means square root of d. So this is basically your E. And once you know E, then you can use this particular formula, these two formula to calculate x1 and x2, which is mentioned here. So if there is any question, is there any question? Is this clear or is there any doubt? Is there any question or is there any doubt regarding the same? Okay, fine. Then we can go to the next. This is another example, but I'd like to get into this. In programming number 2 and 4, these are the things that we would I would like you to do. This particular thing was not in the list, but I would also like to discuss that particular thing. I don't have the algorithm for transpose of a matrix, but I'll discuss that also. So this particular exercise number 3 is not there in the list, so you need to add that into the list, which is very simple. Basically, just to give you familiar, there is the whole purpose of these exercises, this 2 as well as the program number 1 exercise, is to make you comfortable with programming language. They are very simple program, and all you have to do is you have to understand the programming language write the program algorithm and write program for this carry out this simple programming exercise, so that you are confident about how to write programs, because in the next semester you will be doing much more rigorous programming, and there is a whole course on numerical techniques and programming, which is compulsory for all of you. In the next semester, there is a course on numerical techniques and programming, which is compulsory for all of you. And in that, the programming exercises will be there, but there are certain things which you will be doing as a lab work. But at the same time, there will be additional exercises, programming exercises that we will be doing as a part of the coursework. So if you are familiar with the programming right now, it is always a good thing. That's the reason we are trying to, we have designed this instruction. Except for the first one, everything else from 2 to 4, they involve multidimensional arrays, one-dimensional or multidimensional arrays, or multidimensional arrays. So, but then there are in the evening around 4 o'clock, Nagaraj sir will discuss the simpler programs. I was since there was some in the afternoon, today afternoon, the electronics sessions were kind of partly cancelled out, so we dropped out the whole electronics sessions right now, and maybe they can conduct it tomorrow afternoon. So that's the reason I got into this and discussing this. Otherwise, Nagaraj sir would have discussed the programming 1 and 3, which are relatively simpler, without any much of arrays. But then it uses loops, and there could be repetition things, and the certain programs are simpler for in that programming 1 and 3. Here there is an introduction of arrays. But before we get, we will. What I'll do is I'll discuss the algorithms, and then we go back to the programming language and see how to write the program for some of the cases. In addition to this, in programming 4, we'll be sticking to this. Right now, is there anybody who doesn't have laptops or mobiles, laptops or desktops? Is there anybody who does not have laptops or desktops? I'm sure many of you may not have laptops or desktops. So if you, that's the reason I wouldn't like to get into this part. But in case if we have to go back to the classroom, if the university and the department decides that we would continue this with the sessions will be continued with in the classroom, regular classroom teaching, and then and there at least the labs part. Then the labs will have we can make laptop desktops available for you so that you can carry do these two exercises. But GNU plot can be done on a mobile phone also. So if there is I don't I'm sure all of you should have a mobile phone also with you. If you have a mobile phone, you should be able to smartphone. If you have a smartphone, you should be able to use GNU plot. So I'll discuss what are the things that you can do with GNU plot. Okay. First, let us look at these algorithms for different these 5 algorithms. First 5. Look at the first 5 algorithms, and then we will go to the GNU plot. So algorithm is very simple. When you want to divide two complex numbers, a plus ib, a minus c plus id, this is the result. You read in ABCD. So read in the AB, which is real and imaginary part of the first, real imaginary part of the second. Calculate the denominator, which is common, which is c square and d square, c square plus d square. Calculate the numerator, first numerator. Calculate the second numerator over here. Then the real part is nothing but numerator 1 upon denominator. Imaginary part is numerator 2 upon denominator. And then print real part is this, imaginary part is this. That's it. That's the algorithm for writing complex numbers, and you can convert this into program very easily. Then is there I don't think there is any confusion in this. This is one of the simplest exercise. Bubbles. This next one was sorting. Bubble sort. By bubble sort means if you are given a set of numbers and would like to sort them in ascending or descending order. So what you need to do is how many numbers are to be read. Once you read in the number, you read number of data points. You read in the data into an array called, let's say, data. This is an array which stores the values. Then you say set swapped is equal to false. Swapping means interchanging. Swapping is interchanging. You swap two numbers between swap two numbers. That is called interchanging of two numbers. So if you say swap is equal to false, if data I, you start with I, there should be one more step. There should be one more step here somewhere. I is equal to 1. I is equal to 1, and then we say if data is equal to data of I is less than data of I plus 1. So D1 is less than D1 D2. Then you interchange them. Here we are sorting from maximum to minimum. So you sort them swap them, interchange them, and then say that the swapping is true. They are interchanged. If there is any interchange happening, which means that the sequence has not been updated. Every time this swapped becomes true, which means that the number has been interchanged. So if it is changed, if it has interchanged, then swap is equal to true. Otherwise you go to step number 4, step number 9 until which says repeat step number 4 to 8. It's actually it should not be 4, it should be 3 to 8. So if it has interchanged, you go back to the upper one, and then repeat this exercise. Sorry, no, this is right. This is right. Yeah, this is right. Yeah. Repeat step number 4 to 8. Oh, sorry, this is, yeah. Repeat step number 4 to 8 until not stopped. So you repeat from here to here. There should be one more step. I think this is missing. One more step. There should be one more step. Repeat 3 to 9. 3 to 9. We need to repeat 3 to 9 again until you get no swapping. So the procedure is the following. You take two numbers, let's say 1 and 2, and see if there is one is less than 2 or not. If one is less than 2, interchange them. If it is not, then go to 2 and 3 and then see whether it is whether it can be interchanged or not. There are 3 and 4, 4 and 5, 5 and 6, 6 and 7, 7 and 8, and so forth till the end. After doing this, you go to number 2 and 3, 3 and 4, 4 and 5, and do the same exercise until you find that there is no swapping done at all. So when you carry out this exercise until no swapping is done, which means that you have sorted the whole set of numbers. That is called bubble sort. Actually, it's not bubble sort, it's some other sorting method. It's not really bubble sort. Bubble sort is somewhat different, slightly easier to understand, but this is a sorting method. If you have any doubts about this method, try to understand well, you can ask the questions anytime. Let me see if there any. If you, I can't see, I think you should unmute yourself and speak out because I can't hear you. I can't read your messages. Okay. Addition of two matrices. So you read in dimensions of two matrices. The two matrices should have the same dimension. R1 is the number of rows of matrices A and B, and C1 is the number of rows of number of columns. So it's you read in the same thing, and then you read in the matrices A and B. You need to read them. How do you read them? For I is equal to 1 to R1, or J is equal to 1 to R1, read Aij. Read Aij. This is the algorithm. This has nothing to do with specific programming. Read Aij and then end the loops I and J, both loops, and you repeat the same part for B matrix. So this way you read in first A matrix, then you read in B matrix. Both will have the same dimensions. And then let C be the new matrix. Then you say I is equal to 1 to R, sum is equal to 0, and then for J is equal to 1 to 2, C is Ij is nothing but Aij plus Bij. Actually, this is not needed. This is not needed. This sum is not needed. You can do the summation. So you add these two numbers and put it in C, and then n loop J, n loop I. This is how you write in construct the C matrix, and then you print the C matrix. The printing will be exactly like this. Instead of the read statement, it will be print statement. Print statement equivalent of that particular programming language. Matrix multiplication. This one which is transpose, which you can work it out yourself. I'll discuss the programming language. When I discuss the programming language, I'll discuss how to write it. And these algorithms are something which you can find out anywhere on the internet. but I would like to discuss how to write a program. So I'll take one example in the afternoon, after the lunch. Okay. Yeah. So it looks matrix multiplication is given as like this. So this is the product matrix C, and the formula is given like this: Aik into Bkj, where K is the column of A and B. K is the same as the row with this row of B matrix. How do we do this? First, you input matrices A and B. How do we do that? A and B may have different dimensions in this case, but the number of columns of A should be same as the number of rows of B. That is the condition for matrix multiplication. So there is no question of doubt about that. Apart from that, the procedure of reading the matrices will be exactly very similar to the earlier one. Then let's see the new matrix of appropriate size, which is number of rows of A into number of columns of B. Now, for I is equal to 1 to R1, where R1 is the row of A matrix, then J is equal to 1 to C2, where C is the column, C2 is the column of B matrix. R1, R2, A matrix will have dimension R1 and R2. B matrix will have dimension of A matrix will have dimension of R1C, and B matrix will have a dimension of C2. The number of there is something common between these two, but rows of A is nothing but R1, and rows of columns of B is nothing but C1, C2. Okay, and then this is something C1 is common to both A as well as B. These are the C1 is the number of columns of A and number of rows of B. Then say let sum is equal to 0. Sum is nothing but Aik into Bkj. And once you do this, set Cij is equal to sum. That's it. That is your C matrix. This is how you carry out the matrix multiplication. We will, when it comes to real, doing the experiments from the next semester on next week onwards, we will. If there are any doubts, we can discuss this in again during the regular sessions. Okay. Yeah. I'd like to discuss. Come back to the C programming language. These are the features which I would like to discuss, but. So after discussing the C programming language features, what I will be doing is I'll write one or two carry out one or two exercises. But before we get into the C programming language, let me just show in brief what is there is one more thing that is to be done, which is basically your where is that? Yeah, this GNU plot. I can take a few minutes to discuss GNU plot, and then I'll come back to C programming language. GNU plot is a plotting tool which is used to plot two-dimensional, basically 1, 2, and 3-dimensional data. You may be able to do the same exercise using Excel and Origin or many other tools are there. But I would like to use GNUplot because it is first of all free, which is secondly it is available on Linux, Windows as well as mobile phones, and a lot of information is available. And many of the scientists use GNUplot. It's not necessary that it is only used by well, a lot of scientists use GNUplot to do the plotting of their data. So having familiar with this will be useful for your next few semesters, especially the project work in the third semester, or maybe in some of the practicals also could be useful. If you are doing it on a Linux machine, you need to do it using a GNUplot. This is the command to be given on GNUplot, and when and if to exit, you can just put quit exit or just Q and enter. It will come out. For example, here. So if you need to do this in a something called terminal. This need to be done in a terminal. What is a terminal? I'll show you. So in a Linux machine, you need to, if there's something, if you are familiar with Linux system, then you may know what is a terminal. But if it is not a terminal, then you just need to open GNUplot in a Windows machine. So if it is available, it could be, for example, it could be available here. So I hope you can see. You may not be able to read it properly, and maybe you need to zoom it out. So this is GNUplot. So this gives me, this is on a Windows machine. On a Linux machine, it may look, you may see something like this. But this looks like a terminal. You need to give the command like this, GNUplot, and you can see this, which is very similar to what I showed here. So use this command, and then you see certain messages, and then prompt will come here on the left side, which says GNUplot. The same thing is with this. This is the terminal, actual terminal, and similarly, this is on a Windows machine. Again, the same GNUplot, then greater than sign. And if you want to quit, just press enter Q and you can exit. To plot, this is a simple statement. It says plot. You can have different. There are various built-in functions, such as sine functions with lines. I'm going to show you the certain demos, mostly in the afternoon after lunch. So this is just to give you an idea about what programming, what GNUplot can do. So it says plot function with lines. I have used the short form for with lines. You can have mentioned this as WITH LINES. I can actually show it here. Plot type X with lines. I hope all of you can see this. This is, you can see this function. Everything is clear here. Similarly, you can plot data. You can plot. You can have data in a particular file, which is column data. So one column is X and other second column is Y. Then in that case, you can do the same thing. You can put in double quotes the file name, and then you say using 1:2. 1:2 with lines. This particular tells me, well, not me. Sorry. This is something which we tell the GNUplot to use the first column as x-axis and the second column as y-axis. I can do the second thing. I can call 2:1, which means that the second column is my x-axis and first column is my y-axis. It can always be done, and you can have multiple data, multiple things. The remaining part here we will discuss when it comes to when I show you the demo. For the time being, you can ignore this part. But what is common is using first column as the x-axis and second column as the y-axis. What are the features of this GNU plot? The features are the following. It can do plot functions. It can plot 2D and 3D as well as binary data. You can carry out plot histograms. You can change ranges. You can set something called ticks. Ticks are something like this. These ones. You can adjust those. Right now, these are adjusted as per 0.5 value, but you can adjust it to 0.1, 0.2, or whatever value. You can change the width. You can change the symbol also. Instead of 0.5, you can say something else also. You can do a fitting part. This is something which we will be doing these things. Oh, sorry, not this. I will not get into the binary data, but will not discuss the binary point. But we'll plot 2D data. We'll plot function 2D data. Then we'll try to create EPS, PNG, and these output files, and manually specify something called keys. Keys are something over here which tells you which plots corresponds to which curve corresponds to which plot. Play around with these features. You can set. You can have more demos. You can download those demos from this particular website. So what we'll do is we'll see certain features. We'll see certain demos of GNU plot as to how to use those demos.